Also from the class of 72, we have Tom Brentnall, who's spent a lot of time at Disney Imagineering, and we'll get to hear about those stories. So Tom.
Thank you, John, for this amazing, baffling honor. I'd like to give you an overview. I had 12 years at a small company where we designed custom projectors and cameras for both Hollywood and the simulator and research type client. And a couple years in between, I've only had 3 jobs. 25 years at Disney was my dream job ever since I was in high school. And there I did more controllers, camera and projector controllers, and at some point got to join the special effects department, which was a lot more fun because there it's called smoke and mirrors, and I was mirrors. In the 5 years since I retired 5 years ago, I've been doing things for fun in my garage, making some neon art projects and kinetic art and things that defy description. Believe it or not, it all started with a pinball machine. This is not the pinball machine. This is what the pinball machine became, but it was something that I wanted to buy. And at age 16, I spent $25 on a pinball machine that didn't work. And my dad says, "Oh, you're going to be sorry." Boy, was he wrong, because it turned out to be the key to my entire career. This speech is a little bit like that show Connections, and you'll see, I think. Oh, something just showed up on the screen that is covering my words. Sorry, this is my first PowerPoint presentation. Ever. Okay, I'll try to just push the buttons there. Oh yes, the pinball machine was interesting for a while. I fixed it quickly and got bored with it quickly and decided to turn it into a science project. And so I took out the relays and stepper switches and built it into, of course, a binary computer. And it could add and subtract and multiply, but not divide, up to 255. Remember, this is in the 60s. Let's see. It's not changing. Sorry. Oh, so that worked out well. Sorry. This worked a lot better in rehearsal. You'd think, being from an entertainment company, I'd have done this before. So let's see. This is either it's like really slow or I'm just ignorant. Not stupid, just ignorant. I'll just try to do this from memory then. Oh, okay, yes. Thanks. That's a good idea. I tore apart my science project. Okay, so my science project did pretty well. I won a few science fairs, and I even got a position at the WestCon show Future Engineers competition, and in LA, which is people from all over the country. And so while I was there, I saw this guy had built this video camera from scratch, put it in a cigar box. I started talking to him because I was really impressed. I had like a relay machine, and he had like a video camera, and I found out his name was Art Froerk, and it turns out he was also going to this place called Harvey Mudd. So, and we both ended up in East Dorm and became friends and sophomore roommates, and as you'll hear later, he played an even more important role in my career. So I got tired of having this thing sitting around my garage, this stupid computer. So I took it all apart and used the relays and stepper switches to make this reaction time testing machine. I don't know if there's anybody here that remembers it, but I brought it to Harvey Mudd, and in the dorms, it was what we used to call something to dissipate, goof off. Basically, you'd start it, and the light would come on, and you have to press a button really fast, and then another light would come on, and then if you did them all right, your timer, which was click, 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 came out and told you what your score was. Somebody here said, you know, the kids at the nursery school on campus would get a kick out of that, you know, probably because it makes clicking noises and bells and lights light up. So they gave it to the kids, and we made some cards to put into sort of like teach them numbers, words, colors, and things like that, and it was a big hit. And so Dr. Seven said, you know, instead of picking from the list of engineering clinic projects that everybody else in my class had to do, I proposed turning this relay machine into an electronic version. And it was accepted, and that became my senior engineering project. And here it is. I took this out of the attic, took a picture of it. I didn't do it alone. I had Cal Whittam and Mike Jost on the team. And together we built this. It worked. We even threw in some blinky lights and bells to keep that visceral attraction that was so popular in the relay version. And we brought the weight down from 50 pounds to like only 35 pounds. It used medium-scale integrated circuits, which was new to me. I thought it was awesome. NAND gates and flip-flops. Optical reader was built in, so when you put the card in, you didn't have to turn any dials. And unlike the old machine, if you got a wrong answer, instead of locking up and you had to start over again, it just waited until you got the right answer. And that was kind of a suggestion from Dr. Seven that, you know, kids don't want negative enforcement. Originally, I had designed, you know, right and a big wrong light. No. If they get them all right, give them a star at the end. So we did that. So if they got them all right with no mistakes, then they got a big star. Oh, yes, the kids like that. And I'd really like to give much appreciation to Dr. Seven, not only for being my advisor on this project and telling me to think outside the box and, you know, don't always go by the rules. I mean, the rule was you had to pick your project from this list, and I got to do something that was really fun, and it turned out to be an important part of my career. And also, thanks, Dr. Seven, for instilling in me the importance of the human side of a human-machine interface. I kept that in mind in all the things I designed for Disney. So I was proud of my project. I took it to this engineer friend of, an engineer father of a friend of mine from high school, had this little one-man company, but he did special cameras and projectors. Okay, and he was doing this 70-millimeter projector for a nuclear power plant visitors information center on the Columbia River, and he wanted it to be robot, you know, operatorless, and he was using diode transistor logic, not the chips, but diodes and transistors. So he said, you know, I could use someone with integrated circuit control experience. Well, that was my machine. So he offered me a job, and I took it, and I liked it, so I stayed there 12 years. Learned optics and some analog control, motor controls and things like that from him. And together we made a Hale camera for the National Center for Atmospheric Research in Boulder, Colorado. And the thing I was most proud of, a simulator projector for Boeing. Is that right? Oh, one more. That was computer controlled, and it had to go from a dead stop, accelerate from 0 to 40 frames per second on the first frame in 10 milliseconds, and stop just as fast, and go it in either direction, and do it with 30 pounds of film on 3,000-foot rolls, and we finished it. It wasn't on time, but we finished it. We also built this thing called a hologon projector that used a scanner of mirrors rather than stopping and starting the film. It continuously, like a tape recorder, allowed you to play movies really, really fast. Like we built one machine, just went 10 times as fast, 240 frames a second. And we even built one for the Navy that was used to test FLIR camera systems. Speaking of camera systems, backing up here a little bit to my childhood, when I was 3, my dad bought this Kodak still 3D camera. 3D was really big in the early 50s. Fortunately, it's back. fortunately for my career anyway. My dad took us to Disneyland a year after it opened, and he took 3D pictures of us. I have these awesome shots of Disneyland in the old days that are viewable in 3D. And somehow both Disney and 3D has been in my life ever since. So when things got slow where I was working at Woltz's after the 12 years, and I called my old roommate, Art Frowerk, who had become the manager of electronics at WDI, Walt Disney Imagineering, lucky for me. So he got me an interview, and I went up, and unfortunately, they were laying off and not hiring. So I had to go somewhere else. So a couple of years I spent doing things that were completely different. It was like high quantity stuff instead of one-offs, which I much enjoy the one-offs by comparison. So anyway, in '87, I got a call from Disney. They said, you know, we're gearing up for Euro Disneyland. We could use someone that has projector experience. I said, okay. So Art became my boss. And this is a board that went to this Disney fan convention called D23, Anaheim Convention Center, that Disney people come, and I volunteered to show off the Disney 3D rig. And this board here showed the different movies that it had made for the parks. The first two were before I joined, and the others were all stuff that I had input on. I even got to work with Jim Henson on the Muppet Vision 3D. Those are an amazing group of wackos. And it soon became known at WDI that I had 3D film camera experience as well as projectors. So they put me in charge of modernizing the Disney special venue cameras like Circle Vision, 3D, Energy, things like that. And this is a picture of the 3D rig before I inherited it. I wish I had time to explain how stupid some of these features work, but they needed me to modernize it. So I added let's see, what came first? Oh yeah, we motorized the interocular and convergence controls of the cameras that control the scaling and the depth perception of the projected video image. And it was on a box that they could actually do it during a shot. So one of the shots with Miss Piggy uses that feature to an advantage. It had, of course, variable speed, time lapse, single frame, so they could do computer-controlled special effects for some of their future shows they had planned. And I added motorized smart magazines instead of these spring belts that slipped and friction that allowed for the change in size of the film take-up and delivery and so on. And that allowed them to rewind the film in the camera, which they couldn't do before, for doing a double exposure, which some special effects you need to like take one exposure in the daytime, wait till it's dark and the lights come on, and then punch it on at a different exposure. Anyway, it was all fascinating to work with these geniuses at WDI. And I even threw in through the lens video capture so they could see exactly what was in the shot while it was being taken. So all the stuff was new to them. As video projectors, I'm talking about video now instead of film, video projectors finally got cheaper and higher resolution and brighter. And at that point, the projection group, which I was in, merged with the special effects department. And that was like, yay, because those people are really creative. I was the only engineer in the department, so, you know, I was the guy that came to and they said, Tom, do we really need to put like a resistor in series with this LED? It's much brighter if I don't. You know? I was like, so these are a few of the things that I contributed to. The Ursula there, I figured out a way to project 360 degrees inside a crystal ball without using a custom lens. Or in Buzz Lightyear face, it's 180 degrees, also without any special lenses. Unfortunately, I wish I could tell you the actual secret. I'll get to something that I can talk about, but I don't have time. The Sebastian head has a tiny, and I mean the size of a box of wooden matches, tiny video projector inside his head to project his animated eyes so he can blink and look left and right and all that kind of stuff. And there's a video snake, video eye snake that I did for Tokyo. The Madame Leota, as we called it, is the lady in Haunted Mansion that talks out of the crystal ball. I worked on, I think, every one of the 5 iterations. Since when I got there, it was front projected 16 millimeter film, and now it's video that's inside, and the ball can float around in 3 dimensions. So my real goal was to kind of invent some way of projecting somehow so that a viewer could see things in 3D without wearing glasses or being tracked or stuff like that. And right after one of the many mass layoffs, there was time and somehow money for me to develop an idea that I'd been nurturing for decades. For this audience, I know this diagram needs no explanation. It's pretty straightforward. If you really want to know the details, you can talk to me afterwards. I can actually talk about this because, as you know, to patent is to publish. The features of it are that you watch 3D, you can look at it in any angle, and 3D still works. Even if you move around, your point of view changes. You can, and it does that without needing to track. Some older systems did that. And you can even have more than one person in the viewing area at the same time. So that was my biggest thing. And then since I retired, I've still been playing around. You remember the speed machine with the buttons and the lights? Well, I taught myself Arduino, took an old Palm Pilot apart and stuffed it with a little circuit board that you see there, and now it's considerably lighter, like less than ½ pound. And not as fun, though. It needs some bells. So I always mentioned some neon and kinetic art. The gears that you see in upper right, the Mobius strip of gears, they actually rotate when the observer comes up close to it. And I know it breaks all the rules of proper gear meshing, but, hey, I had all these gears sitting around that I got cheap. What else am I going to do? And the lower picture is one of my favorite things I call music of the spheres, all pun intended, is where I make music the hard way by throwing half-inch balls at a circle of xylophone bars and recirculating them with an old bicycle wheel. So we're not sure whether this video works. Oh, right. Good. This is one of my favorite themes. For this crowd, I call it reversing entropy. For the regular crowds, it'll be order from chaos. The neon sign I had made, and then there's this mirror that looks like somebody dropped it about it's the size of like a medicine cabinet mirror. But when you view it through just the right point of view, the cracked pieces of mirrors sort of get the right pieces and create order from chaos. And thank you very much.